Hi folks, I just wanted to work a couple of extra examples for you from section 8.5, adding and subtracting rational expressions. So let's take a look at our first example. So our first example is on the front page of your notes down at the bottom. We have x over x squared minus 4 plus 1 over x plus 2. First thing we need to do is try to factor our denominators. So I'm going to start out with this one here, x squared minus 4. Now notice, x squared and 4 are both perfect squares. So this is a difference of perfect squares. And as we know, difference of perfect squares factor using that nice pattern. So this will be x plus 2 times x minus 2. And now we want a common denominator to add these two fractions together. So we want our denominator to have all of the factors in our denominator. So we see that both of them have an x plus 2. The first one has an x minus 2, so therefore both denominators need to have x plus 2 times x minus 2. So the first fraction doesn't have to change at all. It already has both of those factors. The second fraction, though, does not have the x minus 2 piece. So we've got to take the top and bottom of that fraction and multiply it by x minus 2. So 1 times x minus 2 gives us x minus 2. So now we can go ahead and add these two fractions together since they have our common denominator. So we are just adding straight across the top. So we have x plus x minus 2. In this case, those parentheses really don't mean much to us. This is simply x plus x minus 2 over our common denominator of x plus 2 times x minus 2. We can combine our like terms of x plus x. So we have 2x minus 2 over x plus 2 times x minus 2. The last thing we need to know is, can we reduce this fraction? So looking at our numerator, we see that we can factor out a 2. So let's go ahead and do that. If I factor a 2 out, I get 2 times x minus 1 over x plus 2 times x minus 2. And looking at that, really nothing cancels. So that is then our final answer. Let's try another example. This one's on the back side of your notes. We have x plus 3 over x minus 2 minus that entire second fraction, 6x minus 7 over x squared minus 3x plus 2. So our first step is to factor our denominators to see what we're working with. So the first binomial, we can't do anything with that. But the second trinomial, we actually can. We can factor that using our shortcut because that leading coefficient is a 1. So we're going to have x and x. We want two numbers to multiply to give us 2, but add to give us negative 3. So that'll be negative 1 and negative 2. So looking at our denominators, we have an x minus 2 in common, and the x minus 1 is not common. So therefore both denominators need to be x minus 2 times x minus 1. Essentially what we're doing here, finding our common denominator, is we're finding every single factor in each denominator, and we're making sure that each factor from each denominator is represented in our common denominator. So our first fraction has x minus 2, so therefore our common denominator has x minus 2. Our second denominator has x minus 2 and x minus 1, so our common denominator has x minus 2 and x minus 1. Okay, so what do we need to do to our numerators? Well, the second fraction, we didn't change anything, so it's going to stay 6x minus 7. And notice that 6x minus 7, we can't factor that. It is what it is. And in the first fraction, we have to multiply the top and bottom by that x minus 1. because that wasn't present originally. We had to make it to give our common denominator. So we have then x plus 3 times x minus 1. Okay, so if I go ahead and subtract across the top, what I'll have is x plus 3 times x minus 1 minus, now please remember, we are subtracting this entire numerator. So it's minus 6x minus 7 in parentheses. That is over our common denominator of x minus 2 times x minus 1. And now we need to go through and FOIL these first two binomials and then distribute our negative through to the second binomial. So first off, FOILing, we got to take x times x times negative 1, and then we need to take 3 times x and 3 times negative 1. So we get x squared minus x plus 3x minus 3. And now distributing that negative through, we have minus 6x plus 7. Well, we need to start combining some like terms. So we have on top an x squared. Go ahead and cancel that out. We have 3 x terms. So negative x plus 3x is 2x. 2x plus a negative 6x is a negative 4x. And then we have negative 3 plus 7. That's a positive 4. And this is over x minus 2 times x minus 1. Well, okay, we got it all added together. Now the last thing to do is to see if we can simplify this fraction. So we need to factor that trinomial on top. So we need two numbers that when we multiply them give us positive 4, but when we add them give us negative 4. Well, that's going to be x plus, oops, I'm not plus anymore. It's going to be x minus 2 and x minus 2. Okay, well, looking at that fraction now, we see that an x minus 2 is going to cancel from the top and bottom. So our final answer here is going to be x minus 2 over x minus 1. All right, let's do one last example. This is on the bottom right corner of your notes. And this one we're adding and subtracting 3 fractions, okay? So this is actually going to be kind of a long one like we had yesterday in our notes. So if you need a separate sheet of paper to write this one out, please feel free to do that. So first thing we do, just like with all of these, is we try to factor our denominators. Nothing we can do here, nothing we can do here, but this one is a difference of perfect squares. So it's going to factor into x plus 5 times x minus 5. Okay, and again, because 5 times 5 is 25. So that goes away. Now, our denominator has to have every factor represented. So every denominator has to have an x plus 5, an x minus 5, and an x plus 3. So our denominators are going to be x plus 5 times x minus 5 times x plus 3. And that goes under all 3 fractions. Okay, so there's that. Next, we need to see, well, what happened then to the numerators? Well, in our first fraction, it has the x plus 5 originally, the x minus 5 originally. It's missing the x plus 3. So therefore, we have to multiply the top by x plus 3 as well. We already had an x plus 3 there to begin with. We now need to multiply by another x plus 3 to get that common denominator. And notice, if we cancel those out, we get back to what we started with. Okay? So I actually don't want those canceled out. I'm not able to erase that at this point, so we'll just have to write over it again. All right. So then in the second fraction, we already have an x minus 5. But we need then the other two binomials. So we already have an x minus 1 from the numerator. We also need to multiply by the x plus 5 and the x plus 3. And again, notice, if I cancel out the x plus 5 and I cancel out the x plus 3, I'm left with what I originally started with as my fraction. And looking at the last fraction, we already have the x plus 3, so we need to multiply by the x plus 5 and the x minus 5 on top. So we have 3 times x plus 5 times x minus 5. And again, as I said, if you cancel these guys out, cancel those guys out, top and bottom, then you're going to be left with what you started with, 3 over x plus 3. All right, so let's go ahead and take a look at what we have now. We have a lot of multiplication to do. All right, so in this first fraction, I've got to FOIL this trinomial, or these two binomials, excuse me, to make a trinomial. So I'm going to do that quick. We have x squared plus 3x plus 3x plus 9 over our common denominator. In the second fraction, I'm going to go ahead and just FOIL these two first. Okay, so just foiling those two binomials, I'm going to get x squared plus 5x minus x minus 5. And remember, that is then still going to be multiplied by x plus 3. And that is still over our common denominator. Looking at the last fraction, I'm going to go ahead and FOIL these two binomials together. So we have an x plus 5 and x minus 5. Well, hey, that's exactly what we had up here, x plus 5, x minus 5. When I multiply those together, I'm going to get x squared minus 25. And this is also over our common denominator. Okay, so still working. We need to do some simplification. I can combine like terms here, and I can combine like terms here, and I can distribute this 3. So I'm going to take a moment from the video, I'm going to pause here, and I'm going to go ahead and write that out. Alright, so I have that all multiplied out now. I just combined 3x plus 3x. I combined 5x minus x, and I distributed the 3 through that binomial. Okay, well I still have some work to do. This is a pretty intense problem here. Alright, so I need to go through and multiply this trinomial times this binomial. So what that means is I've got to take x squared times x times 3. I need to take 4x times x times 3. And I need to take negative 5 times x times 3. Okay, so I'm going to go ahead and do that, and I will fill out everything else first. I'm going to pause here a moment. Okay, so I have everything else just copied down. All I need to do is that foiling. So x squared times x is x cubed. X cubed. X squared times 3x is a positive 3x squared. 4x times x is a positive 4x squared. 4x times 3 is a positive 12x. Negative 5 times x is negative 5x. And negative 5 times 3 is a negative 15. Okay, so we can go through and combine like terms at this step. I'm actually going to take a moment and rewrite this on my next page. Okay, so I've got my problem copied down here. I can go through and combine some like terms. I've got a couple of x squareds here. I've got a couple of x's here. Okay, so I've done my combining the like terms. I get 7x squared and 7x. So now comes the time where we can finally go through and add these three fractions together. Bear with me, folks. I realize this is a big problem, and you guys can do this. You just got to be diligent, okay? Take it in small steps. Maybe take a break halfway through the problem so you can get through it all. But you can do it. Okay, so now what we want to do is we are going to add this all together in one big fraction. The denominator is x plus 5 times x minus 5 times x plus 3. Finally, we only have to write that thing once. And we're going to go through and add or subtract across the top. So we have x squared plus 6x plus 9 minus, now remember, we are subtracting this entire polynomial. So really, we have to distribute that negative through each one. And rather than having to rewrite the problem yet again in doing that, I'm going to actually distribute that negative at this step. So we have minus x cubed minus 7x squared minus 7x plus 15. And then on the end, we have plus 3x squared minus 75. Okay, combining some like terms. We're almost done. Light at the end of the tunnel here. We have a negative x cubed. Done with that one. We have x squareds all over the place. X squared here, negative 7x squared there, 3x squared there. So we have negative 3x squared. Then we can combine x terms, 6x, negative 7x, so that's a negative x. And combining constants, we have plus 9, plus 15, minus 75. So 15 and negative 75 is a negative 60. Negative 60 plus 9 is a negative 51. All right, the last thing I see, we have a leading x variable that is negative. We don't like that. So the very last thing to get our very final answer is to factor out a negative 1. So we have negative 1 times x cubed plus 3x squared plus x plus 51. All over our common denominator of x plus 5 times x minus 5 times x plus 3. And yes, folks, finally, we are done with that problem. Okay, folks, very important piece, your homework for today. Your homework for today is section 8.5, the practice worksheet. I need you to do 1 through 4 and number 9. Now, 1 through 4, all you're doing is finding the common denominator. You're not adding or subtracting these fractions together. You're just finding the common denominator. And then number 9 is one of those where you're adding 3 fractions together. It's kind of a longer problem, okay, but not quite as long as the ones we did in the notes. So you must do those 5 problems, okay? But then, for the rest of the worksheet, you just need to pick 3 others. Any 3 others you want, okay? So therefore, your entire assignment is 8 problems long. 3 of them you get to choose. Good luck, folks.